Hi, welcome to my project bazaar.com. Now we are going to see the process of redundancy management of multipath routing for intrusion tolerance in heterogeneous wireless sensor network. Here is the abstract of our process. To propose redundancy management of heterogeneous wireless sensor networks utilizing multipath routing to answer user queries in the presence of unreliable and malicious node, and also analyze the lifetime of a heterogeneous wireless sensor network while satisfying the reliability, timeliness, and security requirements of query processing application. We developed a novel probability model to analyze the best redundancy levels in terms of path redundancy and source redundancy. It satisfying the reliability, timeliness, and security requirements of query processing applications. Each node uses a set of anomaly reduction rules such as high dependency in the sensor reading or recommendation has been used. A packet is not forwarded as requested, as well as interval, retransmission, repetition, and relay rules. If the count exceeds a system defined threshold, the neighbor node that is being monitored is considered compromised nodes. And also, as well as the best intrusion reduction settings in terms of number of voters and the intrusion invocation interval under which the lifetime of a heterogeneous wireless sensor networks is maximized by using distributed voting mechanism algorithm. Let's move to one DFT of our process. The first one is the network formation. Here which we represent the nodes and the exposure and Y portion of the network. And also moves to the cluster formation. In cluster formation, before that we have to evaluate the Euclidean distance between each nodes. Based on the distance, we have to evaluate the cluster formation. So the cluster formation is considered two steps: cluster head and sensor node process. So each cluster consists of one cluster head and remaining also sensor node. So the cluster head and the cluster head is also communicated, and the cluster head to sensor nodes also communicated. Then moves to attacker identification process. In attacker identification process, we move to one distributed voting mechanism algorithm. In distributed voting mechanism, we want to recover any other queries from any of the node means we first consider the surrounding nodes of the monitoring nodes, then evaluate the feedback from the surrounding nodes based on the voting mechanism. After that, evaluate the votes from nodes and also identify the intruders based on the energy and cost consumption. Then we have to easily evaluate the intruders between the presence original nodes, and also the performance also evaluated. Let's move to one demo of our process. It's the home page of our process. Here by clicking network, the overall the network formation will be displayed. Then move to process. Here by clicking node details, so the overall node details are displayed. Then proceed means node positions are also evaluated, the node name and exposure and Y position. Then by clicking Euclidean means the Euclidean distance will be evaluated to each and every nodes. Then clicking extract distance means the Euclidean distance value will be shown in the table. Then moves to process. Here by clicking cluster means the nodes are clustered by 3 groups. And by clicking cluster node means cluster position also verified. So I select any one cluster and click show means these are the first clustering nodes, these are second clustering nodes, these are third clustering nodes. Then cluster heads are also evaluated for 3 cluster groups. Then moves to next process. By clicking cluster means the cluster nodes are also drawn in the figure. Then under cluster head under each and every node names also displayed. Then cluster head to sensor nodes means the line draws between each and every nodes, and also it shows the blue color line, and also it shows green color line. Then evaluate the cluster head to cluster head nodes. Then moves to the process. Here by clicking query data means query data also evaluated, and also by clicking view data set means the data sets of nodes should be shown in the table. Then click query issuer, then query list. Here select any one query type and issue query to PC. Then run pc.java. Here by clicking receive query means the query received. Then clicking surrounding nodes means surrounding nodes also displaying. So neighbor nodes written successfully. Then send query to ch. Here we have to run query node.java. In that process we give receive information. Then also neighbor nodes information also listed. Here select any one node and click sending OT request. If we selected first index means run s1.java. In s1.java receive target node information and transmission time and also the results. Then moves to second index, then click sending OT request, then run s2.java. In s2.java receive target node information, then click transmission time and also result. Then select third index and click sending voting request, then run s3.java. In third node receive target node and also the transmission time and results are also displayed. Then moves to fourth index, then clicking sending voting request, then again also run the s4.java. In s4.java receive target information and also the transmission time and also result. In final we move to the receive feedback form. In that feedback form we first select that in that frame send to query node the sending feedback, and also here by clicking first receiving button the first node feedback will be received, and also the second node feedback also retrieved in that process. The same for third node. There is information will be received, and also the fourth node the feedback also received. Then evaluate the energy between all other nodes, then query, then energy for corresponding 4 nodes. So the energy level calculated for all other nodes. Then moves to process. Here by clicking detect means SN22 is an intruder. So then move to query result. Then click send to PC. Run query node.receive.java. In receive.java by clicking receive data means the receiving file also received. So the first the node click the humidity level to the query node. So the final the query result for humidity will be sent to the user. And also the energy level between the node levels are also represented in the graph, and also the execution time between the existing and proposed system are also evaluated and the efficiency is achieved. Thank you.